Hi students, today we are going to discuss about a brief explanation of a function f of x when the interval is given in terms of pi. Okay, when the given interval in terms of pi, there are three cases of the types of intervals, that is first 0 comma 2 pi, minus pi comma pi, and 0 comma pi. So let us discuss the first one. When the interval is given in terms of 0 comma 2 pi, observe the interval is given as a 0 comma 2 pi, then the formula is, this is the formula which is known as a Euler's formula. Okay, so that is f of x is equal to a naught by 2 sigma n is equal to 1 to infinity a n cos n x plus sigma n is equal to 1 to infinity b n sin n x. Okay, where a naught is equal to 1 by pi integral 0 to 2 pi f of x dx, a n is equal to 1 by pi integral 0 to 2 pi f of x cos n x dx, and bn is equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. Okay, so this is the formula to expand any function asking to expand in interval 0 comma 2 pi. Okay, observe that interval 0 comma 2 pi. Now let us discuss minus pi comma pi when the interval is given as minus pi comma pi. In this case we have three cases, so that depends on the function. If the function is even, okay, if the function is even, and if the function is odd, and another one if f of x, the function neither even nor odd. Okay, let us first go to the first one. If f of x is even, that is f of minus x is equal to f of x. Okay, so that is the even function definition. F of minus x is equal to f of x, the function is even, then we can say the function is even. In that case, when the interval is given as minus pi comma pi, if you observe the function is even, then this is the formula where bn is equal to 0. So where bn is equal to 0, this expansion, now this is the formula f of x is equal to a naught by 2 sigma n is equal to 1 to infinity a n cos n x, and a naught is equal to 2 by pi integral 0 to pi f of x dx, and a n is equal to 2 by pi integral 0 to pi f of x cos n x dx, and where bn is equal to 0. This is the case when f of x is even. Next, coming to the f of x is odd. If f of x is odd, in f of x is odd, that is f of minus x is equal to minus f of x, any function can be written in that form, then we can say the function is odd. In that case, the expansion of f of x as a Fourier series, the formula is sigma n is equal to 1 to infinity bn sin n x, where a naught, a n are zeros. Okay, observe a naught, a n are zeros, and bn is equal to 2 by pi integral 0 to pi f of x sin n x dx. Okay, now come to the third one. If f of x is neither even nor odd, okay, when you observe the function asking to expand the function in the interval minus pi comma pi, and you observe the function is neither even nor odd, in that case we have to find all the coefficients a naught, a n, and bn within the interval minus pi comma pi. So that is, this is the formula f of x is equal to a naught by 2 sigma n is equal to 1 to infinity a n cos n x plus sigma n is equal to 1 to infinity b n sin n x, where a naught is equal to 1 by pi integral minus pi to pi f of x dx, and a n is equal to 1 by pi integral minus pi to pi f of x cos n x dx, and b n is equal to 1 by pi integral minus pi to pi f of x sin n x dx. Okay, so these are the cases when the interval is given as minus pi to pi, when the function is even and function is odd. And in these two cases you have to observe one more thing. Okay, when they are asking to find the f of x function is given as a trigonometric functions, okay, when the function is given as a trigonometric function, and when you finding the an and the bn, you observe the denominator, there you will get n square minus 1. Okay, n square minus 1, so that cannot be taken for n is equal to 1. So in that case you have to find, even though the bn is 0, you have to find the b1 and a1 separately. It doesn't matter when the function is even or odd in the interval minus pi comma pi. Asking to expand the function, trigonometric function like sin x or cos x. In that case you have to find a1 and the b1 also. Okay, remember that, that is a very important point. Next, go into the third one, 0 comma pi. This is exactly the half range. In this we have two types, sine series and cosine series. Half range sine series is nothing but the function f of x, the series contains only sine terms. Okay, the series contains only sine terms. So that is sigma n is equal to 1 to infinity bn sin nx, where bn is equal to 2 by pi integral 0 to pi f of x sin nx dx. Okay, this is known as a half range sine series. Now what about half range cosine series? Here the series contains only cosine terms. So okay, the interval 0 comma pi, observe the interval 0 comma pi. So f of x is equal to a naught by 2 sigma n is equal to 1 to infinity a n cos nx, where a naught is equal to 2 by pi integral 0 to pi f of x dx, and a n is equal to 2 by pi integral 0 to pi f of x cos nx dx. Okay, a naught is equal to 2 by pi integral 0 to pi f of x dx, and a n is equal to 2 by pi integral 0 to pi f of x cos nx dx. And this is how you can expand any function when the interval is given in terms of pi. Okay, thank you.